Hello. I extend my warmest greetings to all. In this video, I will present my project for the TÜBİTAK 2219 International Postdoctoral Research Scholarship Program. My name is Onur. I was born and raised in Ankara, a graduate of Ankara College and Ankara University. I am currently employed at Ankara University, and I am a devoted fan of the MKE Ankaragücü football team. Biometeorology and bioclimatology are scientific disciplines investigating the responses of living organisms to various weather conditions. An integral part of bioclimatology research involves thermal comfort studies designed to unveil human reactions to specific atmospheric events. Environments where thermal comfort declines induce stress on individuals, resulting in physiological, psychological, sociological traumas, injuries, and material/moral damages. Prolonged exposure to conditions below or above thermal comfort levels can lead to permanent damages, and unfortunately, the risk of loss of life, especially for vulnerable individuals, is a pressing concern. Cognitive, affective, and emotional deteriorations caused by heat stress negatively impact daily life and may even elevate the propensity for criminal activities. Early prediction of weather conditions causing heat/cold stress and timely warnings can facilitate risk management, reducing damage to the lowest possible level. Physiological equivalent temperature, PET, and modified PET, IMPET, are widely used thermal comfort indexes globally. PET and IMPET assess the response of thermoregulatory mechanisms, maintaining human heat balance based on meteorological parameters such as air temperature, average radiant temperature, wind speed, and humidity. The origin and development of the PET index took place at the German Meteorological Service, DWD, Human Biometeorology Research Center, which produces daily, weekly, and monthly biometeorology bulletins and implements early warning systems for health risks, particularly in extreme weather conditions. Establishing a similar system for densely populated cities with potential thermal risks in Turkey will help minimize health and safety risks. All environments where thermal comfort is compromised induce stress on individuals. Increased stress leads to various physiological, psychological, sociological traumas, injuries, and material/moral damages. Prolonged exposure to environments below or above the thermal comfort value can result in permanent damages, and unfortunately, there is a risk of loss of life, especially among individuals in vulnerable groups. Cognitive, affective, and emotional deteriorations caused by heat stress negatively impact daily life and may even elevate the propensity for criminal activities. Predicting weather conditions causing heat/cold stress and issuing early warnings can facilitate risk management, reducing damage to the lowest possible level. The primary factors determining the climate of a location on Earth can be categorized into 5 main headings. 1. The amount of energy received from the sun. 2. The heat retention capacity of surfaces. 3. The heat retention capacity of the atmosphere. 4. Hydrometeor quantity and transfer characteristics. And 5. Local and global air circulations affecting the region. Cities, inherently unique in nature, harbor distinct climate features. In urban areas, depending on the structure, building density, energy transfer, radiation, conduction, convection, thermal conditions, albedo rates, thermal conductivity, specific heat capacity, humidity conditions, evaporation, precipitation, surface runoff, soil infiltration, and air circulations, wind frequency and speed, vary. Consequently, climatic and bioclimatic conditions differ from areas with natural materials and patterns and even among other cities, despite receiving an equal amount of solar energy, leading to varying responses. Physiological equivalent temperature and modified PET are widely used thermal comfort indices globally. The selected PET in this research evaluates the response of thermoregulatory mechanisms that maintain human heat balance based on meteorological parameters such as air temperature, average radiant temperature, wind speed, and humidity. This index is fundamentally based on the Munich Individual Energy Balance Model and Gaga's 2-node model. Meteorological conditions in open spaces are calculated considering human heat balance. The conditions faced by a 35-year-old male, 175 centimeters tall, engaged in 80 watts of work, with clothing thermal resistance of 0.9 kilo, are equated to typical indoor weather conditions. Aligning outdoor conditions with indoor responses results in a concrete comfort index. The German Meteorological Service Human Biometeorology Research Center is where the PET index was developed and is currently used. It produces daily, weekly, and monthly biometeorology bulletins and has developed warning systems, particularly for health risks in extreme weather conditions. Developing a similar system for cities in Turkey with dense populations and potential thermal risks will serve to minimize health and safety risks. The alignment of outdoor conditions with indoor responses yields a tangible comfort index. The climatic assumptions referenced in the typical indoor space are outlined below. The average radiant temperature is equal to air temperature, TMRT equals Ta. The wind speed is 0.1 meters per second. Water vapor pressure is 12 hectopascals, corresponding to Ta equals 20 degrees and relative humidity around 50%. In the MS index, age, gender, and clothing insulation values can be adjusted. In this context, MS proves to be more practical for analyzing thermal comfort conditions during cold periods. The research will involve the calculation and comparison of FES and MS values. Rayman Pro copyright software will be utilized to compute FES and MS values. This software has been developed at the Human Biometeorology Research Center, where the study will be conducted. The dependent variables to be used in the research include temperature, water vapor pressure, wind speed, and cloudiness. These data will be obtained from meteorological stations affiliated with the German Meteorological Service. Meteorological stations will undergo major homogeneity tests, and non-homogeneous stations will be excluded from the dataset. As meteorological stations provide point measurements, the values obtained need to be interpolated to form a spatial dataset. The independent variables to be used in the interpolation process, namely latitude, elevation, and maritime data, will be generated by the researchers using ArcGIS 10.8 software. Land use data, another independent variable, will be obtained from the European Union Copernicus program. The interpolation analysis between the obtained dependent and independent variables will be conducted using the multiple linear regression method with ArcGIS 10.7 software. The research will utilize temperature, water vapor pressure, wind speed, and cloudiness data obtained from selected meteorological stations under the German Meteorological Service. Point measurements from meteorological stations will be interpolated and spatially analyzed using ArcGIS 10.8 software, considering latitude, altitude, maritime data, and land use data as independent variables. The interpolation analysis will employ the multiple linear regression method in ArcGIS 10.8, and the resulting maps will be converted into climatological models using Python 3.10.2 software. Models will predict the severity and impact of heat stress under specific weather events, utilizing the facilities of the German Meteorological Service Human Biometeorology Research Center. Outputs, including maps and models, will be disseminated as easily understandable products for decision makers and end users. Findings will be shared with national and local authorities, and research results will be published in peer-reviewed journals. As I conclude my presentation, I extend my sincere regards to all of you and express my gratitude in advance for your evaluation. I wish you days filled with health and hope.